Hi, I'm Guillaume from ViewComfy, and today I'm going to show you how to configure your ComfyUI deployments on ViewComfy so that they can handle multiple users at the same time. So for those of you that already know us, we provide the tools to run and deploy ComfyUI workflows in the cloud or to turn those workflows into applications that can easily be shared with your team. So whether you're using ViewComfy to turn workflows into APIs or apps, this is probably relevant to you. So here I've got a deployment already ready, and I'm just going to show you how to configure it. So first you need to go here, click edit. You can change the GPU it's running on. So for example, when you're just setting up your workflow, maybe you want to run it on a small GPU, and then when you're ready to deploy it, move to a bigger GPU to generate faster. But the key parameters I want to go over today are the ones you see here. So these are the parameters that will basically tell your infrastructure how to behave when there's more traffic on your application or API. So the most basic parameters are minimum number of GPUs and maximum number of GPUs. As the name suggests, they dictate how many GPUs your infrastructure will be using at the extreme. So by default, minimum is 0, meaning that when there's no users, your infrastructure scales down all the way to 0. There's no GPU running and you don't incur any cost. If you set this to 1, for example, there's always at least one GPU running. This can be advantageous because it means that if you have a user that comes in, you're guaranteed that they won't experience a cold start, so the generation will feel like it's going faster for them. But obviously there's a cost to having a GPU on all the time. Maximum number of GPUs, so this is how many GPU your infrastructure can scale to. For example, if you set it to 4, you could have 4 users using your application at the same time, each with their own GPU, for example. So that would give them a better experience as things will go faster because they're not put in a queue. Then you've got this parameter here, idle time. By default, it's 30 seconds. And that means that when a GPU is done generating, and if there's no other requests in the queue, it's going to wait 30 seconds, and if nothing else comes, it's just going to shut down. And then once there's a new request, that GPU will have to be turned on again and experience a cold start. Then queue size, so that is the maximum number of requests in the queue before a new GPU is turned on. So by default it is 1, meaning that let's say you receive 2 requests at the same time, and let's say you have max GPU set to something higher than 2. So you receive 2 requests at the same time. Because maximum queue size is 1, both those requests will be sent to a GPU and handled by a different GPU. Let's say you had maximum queue size 2, then you receive those 2 requests, the queue size goes to 2. Our system is going to be, okay, well, 1 GPU is enough to handle that because the max queue size is 2. Then there's this last one, which is a bit harder to explain, but basically what it is how many buffer GPUs you want. So even if you have it set to higher than 0, it's not going to prevent your infrastructure from scaling down all the way to 0 and basically shutting down when there's no demand. But as soon as you start getting demand, the infra will turn on extra GPUs. So the number of extra GPUs specified here. And those GPUs will be there waiting to receive requests. So that's going to mean that if you've got a surge in demand, that less people would experience cold starts as new GPU need to be turned on. There'll already be some GPU turned on and ready to go. So yeah, that's pretty much everything that you can do with those parameters. I'll link the docs in the description if you need more details. Thank you.